Okay, very brief overview of Vaisala Indigo 520. This is Fluidics demo kit that we have a HMP1 RH&T probe and a GMP252 CO2 probe ppm for indoor environments. Quite high numbers on that as well, but it's quite a warm stuffy office and I've been sitting breathing over this probe for the last 10 minutes. It's quite a warm summer's day, as you can see. So it's quite warm in the office, 23 degrees, fairly dry, 41%. You can set up the home screen. Okay, so first of all, we've got 4 parameters shown in the home screen just now. And if you click this little moving on, you can see there's a graph as well. I've only just switched this on to set up the demo, this quick little video. And the input-output status, which shows there's 4 analog outputs, generally 40-20 milliamps, but you can have voltage as well, and a couple of relays on this model. Now I've got them all set off because we're not connected to a PLC or a beacon or anything like that. It's just a bit of demo kit. So let's go back to home screen. You can see RH temperature from HMP1, and we've also put a calculated parameter. We've picked dew point, and then the CO2 value. So if I go to the home settings, the main home settings, so that's my graph. Let's start with the measurements. That screen kind of shows that there's 4 parameters shown on the screen. I could have actually 6 and pick more. I could just keep it simple. 1, 2, you get the idea. It shows you how it's laid out and where each slot, as they're calling it. So the top left, relative humidity, top right, CO2, blah, 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 and you can see up to 6 slots. Oh, big fat fingers. Right, 6 slots. And then the graph, we're just going to graph temperature and slot 2, CO2. We're going to do a graph scale. 1 day. Do you know what? Let's do 15 minutes, because actually that might show where I've switched it on, because I've just put this on. So okay, that's that done. Measurements I'm going to keep the same. Let's go back home. Let's see if that graph's done anything. Hey, voila. There we go. Okay. Just a little bit more. What's of interest? Inputs and outputs. Analog input, you can use this to wire a 4220 into this device, and then you can obviously scale it for what you want. We are not doing that. It would be, to be honest, a fairly expensive display for a 4020 with a retransmission, but you could do it. Maybe you would use the second channel, put your RH&T through in the first one, and then you want something else to come through. Analog outputs, more of interest. So again, like I said, 4020 is most common. If I scroll, that's all looking at us through the camera, so great. Do voltage, milliamps, let's not do that. Now, as you can see, analog output, I've got them all off. I would just put them on, I'll just click that on, not difficult, but I've not got this connected in. If I take a step back, you can see it's all in a box for a little bit of demo kit. So that's the general details. Output 1, okay, wet bulb, more likely you would do that as probe 1 RH. If I wanted to put it on low end, 0 to 100%, that seems common, you can do what you want. And then your error output, do you want to go, what do you call it, burnout high, burnout low, what we've picked here. And the low clipping, I think this is actually Namur, low clipping limit and high. So a 40-20 milliamp, 0 to 100%, it would actually read a little bit less than 0 and a little bit more than 100, although that's impossible in this situation. But if it was temperature, for example, then you would scale it 0 to 100 degrees, but you could obviously measure down to whatever 3.8 milliamps works out to minus 5 degrees or something like that. And I think that's 3.8 to 20.5 is Namur NE43 compliant. Don't quote me on that. Doing that from memory. 4 analog outputs, all set up the same, and a very useful test mode. So regardless of what your probes are measuring, you could force each of the four 4020 milliamp outputs to 12 milliamps, 8 milliamps, whatever you want, just to prove that you configured it correctly in your PLC. Quite often we see people saying, the scaling doesn't look right in my PLC, the numbers don't tie up with what's on the display on the transmitter. And you think, well, what's going wrong? So if you set it to 12 milliamps, you can know it's going to be half out, and then you can see actually it's because your SCADA system is scaled. Instead of being 0 to 100, it's 0 to 150 or something like that. We see that often, so that's a very useful tool. Kind of covers the analog outputs and inputs. 2 relays, pretty simple to set up. Hysteresis, like a deadband, I suppose I would call that. Up and down, so you can reduce chattering if you're sitting right on a set point. And again, test points, you could just switch your relays on and off, just prove they're working. Digital interfaces, we can do a bit of Modbus with this. Active notifications, we don't have any problems. That's kind of all you really need to know. We can put it on the network, we have done that, give it an IP address, and you can talk to it over the network, get up an IP on a browser on your PC, screen locks if you don't want anyone messing about with it. Change your languages, probably don't do that. That pretty much covers it.